Good morning, students. So in our last class we complete up to question number 7. So today we have to continue this exercise, and today we have to complete another two question number 8 and question number 9. So first of all, if you see the question number 8, and the question number 8 is given like in this way: ABCD is a rectangle in which diagonal AC bisects angle A as well as angle C, so that ABCD is a square, diagonal BD bisects angle B as well as angle D. So first of all, here ABCD is a rectangle mentioned, and with this AC bisects angle A and C. That means bisects means what? All of you know, an angle separate into two equal parts. So now here, as you see the diagram, if you see the diagram here, ABC is a rectangle we drawn, and now here AC the diagonal we drawn, and here already marked, if you see DAC, I repeat DAC, as well as if you see the another angle BAC. So these two angles are equal. Reason behind, AC is the bisector, already mentioned here. Similarly, if you see DCA is equal to BCA, as you see in the figure given this one. So now first of all, here we need to prove ABCD is a square. So what is the property of ABCD is a square? So square means all sides are, we need to prove equal, isn't it? And the diagonal BD bisects angle B as well as angle D means we know we need to prove the angles are equal. So first of all, here how can we start? At first we write in triangle. If you see the proof here written in triangle ABC and ADC. So if you see the diagram one more time, ABC and another one is ADC. Two triangles are here we get in this rectangle ABCD, and now here angle BAC is equal to DAC. Already we know why, because AC is the bisector. Similarly, here we write BCA is equal to DCA. Why? Again bisector, so that's why these two angles are also equal. So these two are given, we write at first, and in between these two, which line is common? So for both the triangle ADC and ABC, AC is common, so that's why here we write AC equal to AC, with in bracket we have to write common. So now here two angles and one side equal, so which congruence rule we can apply? Already we discussed in property, so we can apply here angle side angle congruence rule. So that's why by angle side angle congruence rule, what we can say, these two triangles are congruent. So that's why here we write triangle ABC congruent to triangle ADC. Therefore the side AB equal to AD, from which condition we write? By CPCT. CPCT means corresponding part of congruent triangles. So that means these two triangles are if congruent, that means then their shape and size are equal. So from there we can say AB equal to AD as well as CB equal to CD. We write, and after that one thing we know, ABCD is a rectangle. So in case of rectangle, opposite sides are always equal. So that means we know AB equal to CD or DC or BC equal to AD. And from here, if we combine these two, then as a whole we can write here, what we can write? AB equal to BC equal to CD equal to DA. I hope all of you understood this one properly. Very simple one. And the next one is, if you see here, next proved the bisector. We need to prove the diagonal BC bisect angle B and angle D, isn't it? So that's why in this case what you have to write, again we take the triangle ABD. Now second time we take the triangle like in this way. If you see ABD, and CDB. In this way we have to take these two triangles. AD equal to CD, already we proved, because square. AB equal to, also we can write CD. At first we write AD equal to CD, as well as we can write AB equal to also CD, isn't it? And now the third case, BD is common for both the triangle. So how many sides are here equal? 3. So therefore by side congruence rule, what we can say, these two triangles are congruent. Therefore triangle ABD congruent to triangle CBD. So if these two triangles are congruent by CPCT, that means corresponding part of congruent triangle, their corresponding parts are equal. So that's why here we write angle ABD. If you see the diagram, ABD is equal with CBD. Two angles are here we get, as well as ADB is equal with CDB. Here another two angles are equal. So that means from here what we can say, hence diagonal BD bisects angle B as well as angle D. This one is about proof. Is it clear? Okay. Now the next question is here, question number 9. In question number 9, parallelogram given ABCD. 2 points P and Q are taken on diagonal BD. So BD is the diagonal here considered, and in this diagonal 2 points are considered P and Q. Such that the condition is given, the length of DP is equal with PQ. As you see here the figure given, DP and PQ lengths are equal. So 4 conditions are here given. We need to prove APD congruent to CQB, AP equal to CQ, AQB congruent to CPD, AQ equal to CP, and finally APCQ is a parallelogram we need to prove. So APCQ, so the inner diagram here, APCQ, this one is also a parallelogram we need to prove. So one by one we have to prove here. First of all, given ABCD is a parallelogram. So in case of parallelogram, what we know, opposite sides are equal and parallel, isn't it? So now here let's see how can we start this one. So first of all, whatever given we have to write. Parallelogram given, P and Q are the points on the diagonal BD, so that's why BP equal to BQ. These two are equal. We write. Now we need to prove this 5 condition. So now first of all, in first case, if we take the triangle APD, you see the diagram properly, APD and CQB, these two are the triangle we consider. So in these two triangle, if you see here APD and CQB, we can write AD is equal with BC. Why? Already we know opposite sides of a parallelogram are equal, so that's why we write AD equal to BC. Is it clear? Similarly, DP, and one more condition here, DP equal to BQ already given. 2 conditions we get, and after that you see here angle ADP is equal with CBQ. Since AD is parallel to BC, so BD, if you see the diagram, if you draw only the line AD and BC, and if you join the diagonal BD, that means this BD also we can consider as a transversal. If BD is a transversal, then ADP and CBQ, these two are what? Interangles, alternate interangles. Since AD and BC are parallel, so that's why these two alternate interangles are equal. So that's why we write this one, and therefore APD congruent to CQB by side angle side, 2 sides and 1 angle, so side angle side congruence rule we can apply, and these two triangles are congruent. Is it clear? So our main task is just we have to identify the triangle. if you draw the triangle separately, then it is more comfortable, like APD if you draw separately and CQB if you draw separately, then easily we can understand. And by CPCT, AP equal to CQ. Is it clear? Similarly, in third case, if we consider another two triangle AQB and CPD, the same condition we have to apply in whatever we have done in question number 1. So in this case, AQB and CPD, two triangle we take, and then from there the third and fourth condition we get. Is it clear? Same process. Whatever we have done for first and second, third, fourth are same. Just the triangle are different. If you draw the triangle separately, then easily you can understand. And now from here, what we can say? You see here, since number 5, since APCQ, since in APCQ opposite sides are equal. How can we write opposite sides are equal? Already we proved. You see, AP equal to, in question number 2, AP equal to CQ we get. In number 4, AQ equal to CP we get. That's not it. And from these two, what we can say? APCQ is a parallelogram. Is it clear? All of you understood this one? Okay. Thank you.